Hi, today I wanted to talk about immutability in JavaScript. Immutability is an important concept, and programming immutably when dealing with mutable data structures can be difficult. Let's dive into types in JavaScript. There are primitive types and there are structural types. Primitive types include number, string, boolean, and more. And usually when you interface with a primitive type, you're using a primitive wrapper. For example, when you define a string literal with quotation marks, or if you use the newString constructor, you're interacting with this primitive object that wraps this data. But if you check the type of the string that you created, it looks at the data being stored there and tells you that it's of type string. Every primitive other than undefined and null has a primitive constructor. Null is considered a special primitive because if you check the type of null, its actual type will be of object. This is an underlying detail that can be for the most part ignored. Null is a reserved keyword and you can treat it that way, but this tidbit is something that you should keep in mind if you're ever checking a type of a variable that can be null. Then let's jump into structural types. Structural types, unlike primitive types, are not considered data types. What I mean by data type is that when you check the type of a string is just a label for this basic chunk of information. The same with number and boolean, etc. But when you look at structural types, the object type and the function type will contain additional data and will have information on how they can use and manipulate that additional data. These can include underlying methods. There are data structures that are built off of this object type. These data structures include the JavaScript object, array, map, and more. So when you check the type of a JavaScript object, array, or map with the type of operator, it will return object. And these data structures are just instances of this object. Then there's also a function type. It is actually derived from the object constructor, but JavaScript has chosen to distinguish this as a specific type. Now, what do we mean by mutable and immutable? Well, with primitive types, so whenever you copy over a primitive into another variable, or you modify a primitive value, you're getting something brand new. When you create a variable that's equal to a structural type, the value of that variable isn't actually this object. The value of that variable is a pointer to that object. And if you're familiar with pointers, when two things share a pointer, they will end up mutating the same thing in memory. Let's look at an example of working with a mutable data structure, namely the array. Here I assign a brand new array to x. When I pop from y, I expect it to only pop from the y array because I set y equal to x, I should be getting a brand new array. But when I console log x and I console log y, I see that they both have been modified and both the values are the same. Let's analyze what's happening under the hood. When we assign an array to x, we're creating a brand new object in memory. What's actually assigned to the variable x isn't this array itself, but a pointer to the memory location. That's why when you execute the next line of code, y is going to be equal to that same memory location. You pop from y, you're popping from memory location 1, and since both x and y are pointing to the same memory location, when you log their values, they're both identical. To address this, instead of assigning x to y, we can create a brand new copy of x. Let's run through this code again with the modifications. When we assign this brand new array to variable x, this array is created in memory. On the next line, we also create a brand new array. Then we unpack the values of x into this brand new array. Variable y now points to memory location 2. When you pop from y, you're popping from the array stored at memory location 2. And in the final result, x remains unchanged, and y's last element has been popped. Let's look at what happens when we change this to use a primitive type such as number. When we assign the value 1 to x, the actual value stored at x is 1 and no longer a pointer. When we are assigning y equal to x, we look at what's stored at x, and what's stored at x is the value 1 itself, and we assign the same value to y. Next we increment y, and we see in the result that x retains its original value, and y is the only variable that was modified. Let's look at an example using JavaScript objects as well. Here I define a user, and I want to create a brand new user based off the previous user, but just updating some of the properties. But what ends up happening is that when we modify new user, we end up modifying user as well. If you remember, when we define a JavaScript object type, it creates this object in memory, and what's actually stored inside this user variable is a pointer to this object in memory. Therefore, when we assign new user equal user, what's actually going to be stored at new user is the identical pointer to this object in memory. And on the subsequent lines, when we update properties of this object, we are updating the same exact memory location that the user variable is using. This also ties into why we're able to modify properties of the object while still using const. This happens because we're never really reassigning new user or user. Looking at new user, we're never updating the actual value that's stored here. It's always the same pointer to that object. Lines 9 and 10 are just modifying properties of that object. Similar to our array example before, let's say we want to create a brand new copy of this user object. Now when we update new user.id, we don't see an issue. But when we update new user.hobbies, we are actually still updating the same array that the user array is using. The reason for this is that the value stored at hobbies is also a pointer to an object in memory. So if we're updating this new user.hobbies, we should be assigning it a brand new object as well if we're trying to avoid mutations. And the result is shown here. On line 11, we see that user retains the exact same value as when it was initialized. And when we create our new user and update the properties, we see the changes reflected and how nothing has affected the original user object. We can also write this in a more concise and readable manner. When we use a spread operator, we're copying over all the properties in this user object. For example, there could be additional properties down here, and they would all be copied to this new user object. On lines 10 to 11, we were updating what value was stored in the property. We can also do these changes inside this new object we created. Now earlier, when we spread this user object, we copied over all its properties, but because we redefine ID afterwards, we overwrite its value. And the same thing occurs for hobbies, where we overwrite its original value as well. And if we look here, it could get a little confusing, seeing how we're accessing user.id and user.hobbies here. I would actually extract these values up here. And we can also rename the value of these if we wish to. And now when we log these two users, both their informations are completely isolated, and now it's easy to understand what's actually stored in new user since all the updates are occurred as soon as the object is declared. Let's take a look at a more complicated example. We can ignore this code up here for now, but imagine a user looking at the user profile, and they're trying to update their address. We have an address object here, and first they're going to add in their address. Next, they decide to update their zip code from 1000 to 1001, and we expect to keep track of any changes to their address. So at the very top here, we have an address change history array, and we want this array to be updated anytime an address is added or updated. So when the user calls addAddress for the first time, we expect this object to be stored in the array. Then when they call updateCurrentAddress and they update their zip code, we expect the updated address to be stored in the array as well. But the actual result in the address change history array is the same zip code twice. Now let's take a look at the functions above. There are three functions being defined. There's getCurrentAddress, which is supposed to give you the most recent address in the address change history. Then there's addAddress, which adds an entire address object into the address change history. And lastly, there's updateCurrentAddress. This occurs when you want to update a specific field of your current address. For example, this could be street or zip code. Why is this bug occurring? Why when we update the current address is the same zip code appearing on both of the objects inside our address change history? Number two, where are mutations occurring? We're trying to avoid mutations so we can avoid bugs such as what we're encountering now, so it's important to identify where mutations, if any, are occurring. Lastly, how can we avoid these mutations? What can we do differently to avoid mutating these mutable types such as arrays and JavaScript objects? This may be a good time to pause to think of several questions. Why is this bug occurring? If we look at what's happening below, it seems addAddress is adding on an object and updateCurrentAddress is adding an object on as well. But when we update our zip code, the update occurs to both of these objects. I'm going to take a look at updateCurrentAddress first. It calls getCurrentAddress, which either gives us the last element in address change history, or gives us null if there are no elements that exist. Now when we try to update the zip on line 36, we update the zip property, and we push this updated object into the address change history. The first thing I notice is that we're directly modifying this current address. Current address is a pointer to an object in memory. When I modify it and push it into the address change history, I never declare a new address object, and I push on this same pointer back into the array. Number two, where are mutations occurring? We identified one mutation where we are directly modifying a field of this current address object, but this array up here is also an object. When we call push, we're mutating this address change history array. Although in this situation, it looks like there wouldn't be any bugs because address change history is just a global variable that we're pushing to. But mutations can make our code susceptible to bugs. For example, what if there was another piece of code that was taking a look at address change history in a specific point in time? They have a reference to this object and they're not expecting it to change. This can be through an event listener, or maybe you have a dashboard that's trying to display how address change history was an hour ago versus present time. This is an example of how mutations can lead to unexpected bugs. How can we avoid mutating? Looking at address change history, we're pushing a value onto the same array every time, but we can change this by creating a brand new array instead of pushing onto this array. I changed the cons to a let because we are assigning a brand new pointer to a new object in memory. And we can do the same thing to the push below. Next, we want to avoid mutating this object's field directly. I'm going to declare a brand new address object. And now we assign address change history a brand new array with all the same values as before, but we also add on a brand new pointer to a new object in memory. In its current state, the code works and isn't mutating any existing arrays or objects, but there are still a couple improvements I would like to make. This address change history variable is set to let, and this value is changing over time. I would like to be very explicit with how this history is actually changing. Now when someone wants to update the address change history, it's more clear that they should be assigning a brand new history object instead of pushing on to the existing address change history. Even though updated address is only being used inside this branch, I think it makes it more unclear what this if statement is doing, so I'm going to move it outside of this branch. And now we're done. That concludes my updates. Thank you for watching my video. For me, I see these videos as a nice opportunity for me to learn and possibly help someone else. I plan to make a follow-up video where I dive into more patterns for programming immutably with JavaScript. Thank you very much.